All right, we are back with our final breakout session for our Minnesota FTC kickoff. We have team 14188, the CyberHawks, and they're going to talk to us about FTC blocks beyond the basics. Take it away, gentlemen.
All righty. So yeah, we're the CyberHawks, team 14188, and today we're going to be giving a presentation on FTC blocks and different things that we've learned through our years using FTC blocks. It's basically going to be things that we learned to make programs simpler, to make them faster, or just to help you out during your season. So let's jump right into it. So first, we'll start off with who we are. So we're a 3-member team based in Hermantown. This is our 5th year in FIRST, 2 years in FLL, 3rd year in FTC, and we're all freshmen. So really the main thing here is our 2 years in FLL. We started out in FLL and then we transitioned into FTC. And for FLL, we used Lego Mindstorms, which we found to be a really simple program and something really easy to use. But when we transitioned to FTC, we wanted to find a programming software like Lego Mindstorms. So what we did is that we started researching, and then we found the FTC blocks programming software, which is really similar to the Lego Mindstorm type program. So what we're going to be covering today is going to be telemetry, how to use it, how to make bug testing easier using it, how to use functions effectively and how to make them using FTC blocks, vision using TensorFlow and Vuforia, how you can make programs more accurate using that, and at the end, we're going to have a Q&A. So if you want to type some questions in the chat during the thing, we'll be sure to answer them near the end. Well, we won't answer them during the presentation, but at the end, we'll be sure to answer all of them. So first of all, what is FTC blocks? It's a blocks programming software made by FIRST to make programming simple. It's web-based and it uses phones and control hub Wi-Fi. So really on this page, you can see the two pro and con to FTC blocks. It's web-based, so you can use it on Chromebooks or laptops. You can even use it on the driver station or RC phone if you wanted to. You can program the blocks on there. But you have to be connected to the phone's Wi-Fi to begin programming on it, which is the main downside of it. You have to be connected and you have to be internet connected to it. So that's the one major downfall from FTC blocks. Benefits of using FTC blocks, as I said earlier, it's easy for beginners. You don't have to learn syntax. As I was bringing up earlier again, we transitioned from Lego Mindstorms to FTC just because it was so simple. And we didn't want to learn all about FTC and a new programming software at the same time. Then you got the simplicity. There's easy to learn blocks. All you have to do is just drag and drop a block onto the page to make it work. You just have to know what they do and how to use them. Blocks work. Then you got color-coded blocks, like all purple blocks are information, all green are loops, all blue are logic, and it's a really easy software to begin using. So the first subject we're going to be covering is telemetry, the advantages of it, how to bug test with it, and really why a lot of teams should be using it. So first we got what is telemetry. It's a way to display information or variables to the driver station phone. So like in this example right here in this image, down here you can see robot running true, that's a string. And then you got first move done, second move done, and then loop runs. So let's say an example for us at least was during our Skystone season, we had a gripper on a robot that we had to grab the block with, but not all the time we could see the gripper. So we didn't always know whether it was open or shut. So sometimes we had to use the telemetry on the phone to say whether it's open or shut to be able to tell when it was open or shut more efficiently. Instead of having to look down at the robot, you could just see what the robot was thinking on the phone. And then telemetry is a really simple thing to add to programs. All you have to do is add in a telemetry box on utilities. If in a loop, you want to add telemetry update to continually reload the telemetry. So I'll open up FTC blocks right here, and here you can see a telemetry program. So under utilities, then telemetry, you can see the multiple different types of telemetry blocks. So first got is a value block, which it can display numbers, as well as a name with it. And down here, you can see a string, which it's basically just a string is a line of text that you can display. So you can display strings or numeric values using telemetry. And it's as easy as just dragging it into the program, clicking it in, naming it whatever you want, and then just choosing what you want to display, like 12. It's as easy as that to add telemetry to programs. It's a really simple thing to add in, really simple thing to learn about. And another example of how we would use it during the season, just to show a way how you might want to use it during your season, is we had an encoder pod system on our robot. So what we would do is that we would want to go to a certain encoder tick, but we didn't know how far that we would have to go. So what we did is that we had started displaying the telemetry of the encoders, and we would start pushing our robot forward to the point where we wanted to stop. Then we could just look down at the phone and see, oh, we want to go this many encoder ticks. It was a really simple process just to figure out that without having to rerun the program over and over and over to figure out how far you want to go. So the next thing is that I can do a telemetry demonstration here. Let me swap over to this. Here you can see a RC and DS phone. On the phone right now, you'll see beginning a program. And on this, it's the example from before. We have robot running true, first move done, second move not done, and then just a loop run counter that adds 1 to each time the loop repeats. So here you can see how simple it is just to display it on the phone and see it. Another example of how we use telemetry during our season was with our lift system. We wanted to see the encoder ticks on that, so we wanted to go to this value, we could go. So let me swap back to our presentation cam. And now we're going to go into functions, why and how to use them. So first of all, what are functions? Functions are a subroutine that can be called upon to return a value. So basically, a more simple version of that is something that can be ran to give a value. Down here in these images, you can see the running block. This is what you would use to call to the function. And here you can see the actual function. So you could put in this whatever you want to run. So again, here I'll show a quick example of a function program and how easy it is to begin using it. So just an example here. What you can see is we have our run op mode along with the wait for start, and then here's our function. And in this example, how we're using it is we have a loop here that's trying to make all 4 of these variable motors trying to go forward. And here you can see that we're going to keep on going until a certain distance. And then we stop all the motors. So to really stop repetitiveness, if this didn't have functions, what you would see here or over here would be these 8 blocks of code all piled up under here. But just reading this makes it a lot simpler to read. You can tell the difference between if you had all of this piled in there versus just one little block. And we use this exact same concept for our autonomous during our season. What we would do is that we'd have a function for each one of the directions that we want to move. And what we did is that we just have to set a distance that we want to go and the speed that we want to go, then just drag in the function block, and then you could go there. So it makes programs a lot more simple without having to add way more in or a lot less. Up here, we're going to show the different benefits of it more in depth, which you can see here, benefits of functions, code reusability, which you could see in that example back there. Really, you can use codes over and over and over. Another example from our autonomous was that we had our encoders that we wanted to keep on getting values from, but we would have to add in each loop our encoders readings. So what we did instead, we would just add it into a function, then you just had to drag that one block in to begin getting your values. And then you got simplicity is another benefit of it. It's easier to fix errors. For example, if you had 5 different places where you use this exact same code, and then you figured out, oh, there's an error with this. What you could do instead was just to fix it in one place instead of fixing in the multiple different places. It allows for a lot more quicker error fixing during a tournament day if you figure out, oh, I want to change this one value instead of changing it in these 5 different places. Another simple thing about it is that it's easier to read. With that same example, and there's an image up here that makes it simpler to read. It can really make it a lot more of a fluent program for judges to look through. Instead of having to read through this monstrous 1,000 line of code, you could just read through a way shortened, a way more split up piece of code. And then it takes up more space. So if you ever, again, to the judges, it's a lot easier for judges to read a shorter program that's more compact instead of a giant program that's a lot more complicated. So I know it's kind of hard to see here, but on the left, this was our autonomous here. And on the left, you can see this giant piece of code. And that was if we didn't use any functions inside of our program. This is only a partial bit of the program, but it was really long. And you couldn't really see, oh, what's this? What's this? It wasn't really split up well. But on the right here, you can see all our different functions that we use to split up our different sections. You can see we reset encoders here, or we do PIDs here. It really just splits up the program a lot more and makes it a lot easier to read instead of having to scroll through this giant mass of code and have to look for comments and look for a specific area that you want to look into. It can make it a lot simpler to read. How you should tell if you want as a function. If you see a piece of code that used multiple times over, variables that are being written each loop cycle, like I said with the encoders, and a line of code that you want to shorten down. It really depends on how you use your code. You just have to keep an eye out for how you want to use functions. You just always have to look for, how can I shorten this program down using functions? It's not something that might always be obvious, but you just always got to keep an eye out for how you can use them. So the next topic that we're going to be covering is vision, using Vuforia and TensorFlow. So you may be wondering, what is Vuforia and TensorFlow? So first of all, what is Vuforia? It's an SDK software that stands for predetermined images. It gives an XYZ inch value depending on where the camera is relative to the image, usually used on the VuMarks or season challenge. So at first, this may seem like a really complicated piece of line and like, what's this, what's that? But really how you should think about it, I'm going to show an example of how you can use it up here in a little bit. You should really just think about it is that you have this frame, and this robot's looking at this one frame. And what it's scanning for, it looks at the whole entire image and says, I'm trying to look for this one image within this frame. And a good example of this is the sky stone. So try to look throughout the whole entire frame and try to find this sky stone. And it would say, oh, I saw it. Now from here, I'm going to try to give an inch value from where my phone is compared to where my sky stone is. And this is before he's used on VuMarks like this. During Skystone, it's also seen on the wall markers and the bridge markers. It's really used in a lot of different places. So to give an example of it, here we're going to show a Vuforia demonstration. So let me switch the camera. So here you can see the camera right here. And now we're going to be looking for the sky stone that you can see right there. So let me start the program up. And then here you can see it shows the 3 access markers from the sky stone. And if you look at the phone right now, it gives the XYZ value from the phone. So it shows you the X in inches, the Y in inches, and even the degrees of Z. So if we were to move the sky stone more forward, you can see the X value begins getting a lot shorter. But if you move it back, then the X value gets a lot bigger. So Vuforia can be used to get more accurate readings on the field using your resources on the field. So this Skystone was the first season where it actually had a VuMark on the challenge that you're trying to score. But for other challenges like Rover Ruckus, a program that you might want to use instead would be TensorFlow. So TensorFlow is a software that looks for shapes and gives a pixel output depending on where it is on the screen. And it uses the Vuforia software. So really how this looks is with TensorFlow, instead of giving you coordinates of where it is, what TensorFlow gives, let me switch back to the phones. What TensorFlow gives is the pixels of where it is on the screen. So right now it's looking for it, and now you can see in the left it shows the pixels. The top image on TensorFlow is what it originally sees, and the bottom is the manipulated image by TensorFlow. And TensorFlow not only can look for one thing, it can also look for 2 objects as well. So it's not just limited to one, and you can see all the different pixel values from this. So just an example of how we use this program software is during our Rover Ruckus season. What we did is that we had the cube in one of the 3 different places. And so we said, hey, let's look for the cube among us. And we knew that between 200 and 300, it would be in this position. If it's between 300 and 400, then it's in this position, so on and so forth. So basically, you can really use these programs however you want. It really depends on the season challenge, whether you should use Vuforia or TensorFlow. If it has a VuMark on the actual relic, you may want to start using Vuforia. But if it's a shape-based challenge, like Rover Ruckus, or even just trying to scan not skystones, but just stones, you'd want to use TensorFlow. So it really depends on the season, which software you want to use. Although Vuforia can be used in almost all seasons because the VuMarks are on the wall. An example of how we use that is during Rover Ruckus, we would drive forward to a coordinate on the wall. So now we switch back to our screen. So there's the TensorFlow demonstration. And now I'm going to show you how to make the Vuforia software. So the making of the program is really simple. It's really easy to make the program, but the harder part is actually understanding the software. So to make a Vuforia program, it's just as simple as clicking on Make a New Op Mode, click Sample, and then just click Concept VuMark Detection. Then you would click OK. And another cool thing about Vuforia and TensorFlow is that every season they're updated. So each season they release a new program to detect for the new objects. So it's really simple to make this. They already have sample programs for this, and they already have all the codes written out. But the hard part is actually understanding the program. So right now I'm going to do a quick run through of a Vuforia program, just to explain the basics of it and how it works fundamentally. So your Vuforia program. So the Vuforia program is split up into 5 different pieces. There's 5 different functions that it uses. And as you saw earlier with TensorFlow and Vuforia, that used telemetry to display the coordinates on the phone. So you can really see functions in telemetry being used in a lot of different programs. In advanced programs with like vision, you can see the 2 different things that I talked about before in a lot of different softwares. So let's start going through this. So the first thing it does is that it inits Vuforia. And that's a function down here and uses this block. So what you can do with this block is that you can change what camera you want to use and whether you want to use the front or back camera of the phone. We usually use the back, but if you have to use the front or something like that, you can using this. Another cool thing that you can do with this block is using these areas right here. What you can do is that, let's say your phone's on the back right of your robot. And what you can do is that you can use inches to move your phone so it thinks it's in the middle of the robot. So it'll give you coordinates more according to your robot's position instead of where the phone is. So you just have to measure out and say, oh, it's 5 inches this way and 5 inches back to get to the center of your robot, if that's how you want to use that. So the next thing that software does, it initializes, then it begins this loop. And in this loop, you can see a lot of different things. But let's say you only wanted to look for a stone target. You could get rid of all these different things. These are all the different scannable things during Skystone that it could look for. But let's say you just want to look for the stone target. The first thing it would do is that it would see, is target visible, which is another function down here. Is target visible would basically just look throughout the screen and see where it is. And it would say whether it's visible or whether it's not visible. If it isn't visible, what it would do would just say no targets detected. But if it was visible, then it would begin process target. And what process target does is it basically uses the pre-built blocks, the Vuforia tracking results and all that stuff, to give you where the X, Y, Z, and the degrees of where the robot is relative to the stone, which you could see during our example. So with this and TensorFlow, which I'm going to explain the TensorFlow program as well, these programs can be manipulated however you want. Like I brought up before with Rover Ruckus, we would only look for 2 of the stones and leave out 1 of the stones. So we would only be scanning for 2, but if we knew that the 2 weren't it, then we knew the 3rd position was it. So these programs can be manipulated or changed up. They aren't like set in stone. You can change them up however you want depending on how the season is, which we don't know yet, but really excited to see how the season for the new challenge is going to be. Another cool thing that you can do is that if you want to centimeters, meters, inches, or feet, you can do this as well. You usually use inches, but it's really up to preference. So the next thing that we're going to do is explain the TensorFlow program. Boot it up. So as I brought up before, TensorFlow uses the same blocks as Vuforia, but so you can see the same block here. It can do the exact same thing as Vuforia, but this block right here is the main part of the program. This is what requires the most testing, the most bugging, all that type of stuff. It's this one value right here. So what this value does is that, let's say, or example for us is during Rover Ruckus, we would place a robot down, but it began seeing blocks in the other crater. So it'd be like, why is that happening? And then we began looking into the program, and then we found confidence level. So what this does is that it looks across the screen, and it'll say, hey, I'm 70% sure that this is a block, but I'm not 100%. So this determines what the minimum amount of confidence is to determine something as what you're looking for. So this is this one value is something that requires a lot of tweaking. It can change depending on lighting. It can change depending on a lot of different things. So you want to change it up depending on how the lighting is. Like same with Vuforia, lighting can determine a lot of things. If it's very bright, you might not be able to determine the stone. If it's too dark, you might not be able to see the stone. At least for us, we used a webcam that actually had a light on it, so then we could try to narrow out those variables. To keep on going down this program, it activates the camera, press play to start. Then it goes into this. So what it would do here is that it would scan. It would set recognitions. And that what recognition does, it would scan throughout the screen and see how many blocks it sees. If it didn't see any, it would say no items detected. But if it saw 1, what it would do then is that it would go to display info. It would say, I'm going to display how many things there are depending on where the pixels are. So here you can see it would display the left top pixel and the bottom right pixel of the screen. So pixels really aren't an accurate form of measurement, not as accurate as Vuforia. But if you could figure out a way to change it up so you know that at this distance, this many pixels from like here to here equals an inch, you could do that, but Vuforia is a lot more of an accurate program than TensorFlow. So here, so yeah, it would display depending on how many indexes it sees, and it would begin going. That's about it for the TensorFlow. Through here. Some useful resources that you can use throughout your season. This is going to be posted on our website, the presentation. So you could click on these links on our website if you ever want to. Basically, so the first thing is the programming manual. And what that is it explains every single block, and it shows every single block inside FTC blocks, and explains how you can use them. That's a really useful resource. We use it a lot. It explains every single block inside FTC blocks. The second one is a program manual by First. This is a really good resource for new teams, since you can use it. It shows beginner concepts, beginner loops, and a lot of beginner stuff. So thanks for watching. Please ask us if you have any questions. We're going to read off a couple questions that we have in the Twitch chat right now. There's our website link. If you ever have any questions related to the program or anything, you can always email us after this presentation. So the first question we have is, does Vuforia position the robot by a camera? So with Vuforia, yes, it does position it by the camera. You could use the phone camera on the robot. During our season, we used a webcam, but as I was showing before in that one block, you can change where it thinks where the phone is by using those inches. So it may think it's right here right now, but you could change where it actually thinks it is. So initially it does use where it is, but for right now it does use where the phone is. I'll move my webcam up here so you can see the rest of the Gmail. Then we got the second question. How hard is it to program a sensor using blocks? So with sensors, it's actually a really simple thing to learn. We couldn't show you an example right now since we don't have a RevHub plugged in, but it's as simple as dragging a block in and knowing how to use it. I know with like encoders, all you have to do is just drag in a get position block, drag it in, and then you can just get the position from the encoder. Same with like potentiometers, what you can do is just drag in a block that gets the position of it. Same thing with color sensors and a lot of other things. It's really simple to use, put sensors in your program using blocks. So if you have any other questions, you can ask them in the Twitch chat. We got about 5 minutes left. Sure. So while we wait for a couple questions, we can show you the website real quick. If you want to see the presentation, all you have to do is go to more and then FTC blocks presentation, and then it's all just laid out right here. You can see our blocks resources right here, and they just have to load in the presentation, and then you can scroll through all the slides that we showed you. So right now, I think that we're going to be setting up the robot to show you something on it while we use a couple time here. But yeah, ask any questions they have in the chat, and we can answer them while we're doing this. Right now, we're just setting up the robots. Then you can see the potentiometer, how we use it on a robot. For Skystone, we programmed a block, but this year we transitioned to Java. But yeah, for the first 2 years, we were using blocks. Sure. We can show you an example of how we used a potentiometer, how to program a potentiometer. If you don't know what a potentiometer is, I know it's a little bit of a long word. Basically, what it does is it's basically an encoder, but it has limits. You can only turn it a certain amount of ways. For us, we used it on our intake system, and it was a really useful thing for us because we didn't want it to spin all the way. We only wanted to spin partially. Okay. So now I'll try to show how to program a potentiometer, just because that one question in chat, make it a little bit more apparent. Refresh here. I'll just create a new op mode. But create new. Then we got sensors. So here you can see our DC motor. For instance, with encoders, all you would have to do is just drag in this current position block, and then you could just set it to a variable, and that's how you could get your sensor reading from an encoder. You also have IMU, which is really easy to use inside of the system. That's just inside your Rev hub, or also in the control hub. So IMU is a really good sensor to use for beginner teams because it's not something that you have to go out and buy. It's something that you can just use since it's already integrated into your robot, since you have to use a controller Rev hub. So any last questions? Oh, we got one here. Do you use Java? If so, can you give me some information on that? So yeah, we do use Java now. We started learning it this summer. So with Java, really, you can do a lot more with Java. FTC Blocks is a really good software for beginner teams, but Java, you can do a lot more with it. You can program a lot more. You can do a lot more tools with it, but FTC blocks is a lot simpler, but Java does allow you to do more. Another question is that the team that doesn't, I'm on a middle school, would you recommend TensorFlow and Vuforia? So yeah, TensorFlow and Vuforia is a really good software to use. For Rover Ruckus, as I've been bringing up a lot, for our first two competitions, we used a color sensor to go up and scan the stone. But then during state competition, we swapped to TensorFlow, and we could get the program 100% of the time. We always could get our economist to work. So yeah, we would really recommend to dive into TensorFlow and dive into Vuforia and start learning about them, because it's a really cool program to use, and it's really cool to actually see it working. And plus, it's a really useful resource to use.
All right, I think we're done with the questions. I want to thank the CyberHawks for that great presentation. I also want to thank everyone out there for joining us for our the last of our team breakout sessions for the Minnesota FTC kickoff.